Hi dear children, welcome to today's class. Today we are going to continue exercise 6.5, eighth question. At what points in the interval, closed interval 0 to pi, does the function sine 2x attains its maximum value? Sine 2x, the interval 0 to pi, attains its maximum value. That is our question. We need to find out all the points where the sine 2x attains its maximum value in the interval closed interval 0 to pi. Okay, so let it be f of x. F of x is equal to sine 2x. Then f dash of x is equal to, the derivative of sine is cos, so cos 2x into the derivative of 2x is 2. So f dash of x we will get it as 2 cos 2x. Then f double dash of x, that is equal to 2 is constant and the derivative of cos is minus sine 2x into the derivative of 2x is 2 we will get. That is minus 4 sine 2x. This is f double dash of x. Now we are going to equate f dash of x into 0 to get the critical points. That implies 2 cos 2x is equal to 0. This implies cos 2x is equal to 0. Cos 2x is equal to 0. And we know that cos x is 0 when x is an odd multiple of pi by 2. Cos x is equal to 0 implies x is equal to 2n plus 1 pi by 2 comma n belongs to z. Okay, cos x is equal to 0 implies x is equal to 2n plus 1 pi by 2 comma n belongs to z. That means if cos x is equal to 0 implies x is an odd multiple of pi by 2. So instead of x here we have 2x, then 2x is equal to, okay, cos 2x is 0 means 2x, that is odd multiple of pi by 2. 2x is equal to odd multiple of pi by 2, that is pi by 2 comma 3 pi by 2 comma 5 pi by 2 comma 7 pi by 2. Okay, we can take 9 pi by 2, 11 pi by 2 and all, but this value is restricted in between 0 and 2 pi. So x is equal to what we will get, pi by 4 comma 3 pi by 4 comma 5 pi by 4 comma 7 pi by 4. Okay, if you took 9 pi by 2 here, you will get 9 pi by 4, and that 9 pi by 4 that exceeds 2 pi. We can take the values only in between 0 and 2 pi. Okay, so we got 4 values for x, that is x is equal to pi by 4, x is equal to 3 pi by 4, x is equal to 5 pi by 4 and x is equal to 7 pi by 4. Okay, and we need to take, to get the maximum value, we need to get the maximum value and we need to take the endpoints also, that is 0 and 2 pi. Okay, so now we need to find out the value of our f of x. We need to find out the value of our f of x at these points. We need to find out the value of f of x at these points, that is f of 0. F of 0, what we will get? F of 0 is equal to sine 0 we will have, that is 0. Sine 0 is 0. Now f of pi by 4. F of pi by 4 is equal to sine 2 into pi by 4, that is equal to sine pi by 2 is equal to 1. Now f of 3 pi by 4. F of 3 pi by 4 is equal to sine 2 into 3 pi by 4, and that is equal to sine 2 into 3 pi by 4, that we can write it as sine 3 pi by 2. Okay, sine 3 pi by 2, and that is sine of pi plus pi by 2. Okay, sine of pi plus pi by 2, and sine pi plus theta is minus sine theta. So minus sine pi by 2, that is minus 1. Now f of 5 pi by 4, and that is equal to sine of 2 into 5 pi by 4 is equal to sine of 5 pi by 2. Okay, 5 pi by sine of pi by 2, and that is equal to sine of 2 pi plus pi by 2, sine of 2 pi plus pi by 2, and this is equal to sine pi by 2. Sine 2 pi plus theta is sine theta, sine pi by 2 is 1. Now f of next value is 7 pi by 4, and that is equal to sine of 2 into 7 pi by 4, that is equal to sine 7 pi by 2. Okay, sine 7 pi by 2, that we can write it as sine of 3 pi plus pi by 2, and that is equal to minus sine pi by 2. Okay, minus sine pi by 2, and minus sine pi by 2 is minus 1, and one more value is there, that is sine of f of 2 pi, that is equal to sine of 2 into 2 pi, and that is equal to sine 4 pi, it is equal to 0. Okay, sine is 0 at all the multiples of pi, so sine 4 pi is equal to 0. Okay, now just look at this. What is the maximum value of our function? The maximum value is 1. Okay, and we got this 1 at x is equal to pi by 4 and x is equal to 5 pi by 4. Thus the maximum value is 1 at x is equal to pi by 4 and x is equal to 5 pi by 4. Now we are going to do the 9th question. What is the maximum value of the function sin x plus cos x? What is the maximum value of the function sin x plus cos x? 9th question. F of x is equal to sin x plus cos x. In this case, the interval is not given, so we need to find out the local maxima or local minima by using our second derivative test. Okay, so f dash of x is equal to cos x minus sin x, and f double dash of x is equal to minus sin x minus cos x. Now f dash of x is equal to 0. To get the critical point, this implies cos x minus sin x is equal to 0, and this implies cos x is equal to sin x. Cos x is equal to sin x, or we can write it as tan x is equal to 1. This implies x is equal to pi by 4. Tan x is equal to 1. This implies x is equal to pi by 4. Now the next step, we will find out the sine of f double dash of x at pi by 4. That is minus sine pi by 4 minus cos pi by 4. And that is equal to minus 1 by root 2 minus 1 by root 2. Okay. That we will get it as minus 2 by root 2 is equal to minus root 2, and it is less than 0. F double dash is less than 0 at x is equal to pi by 4. That means that x is equal to pi by 4 is a point of maxima. X is equal to pi by 4, that is a point of maxima. Point of maxima, and the maximum value, that is f of pi by 4 is equal to sine pi by 4 plus cos pi by 4, and that is equal to 1 by root 2 plus 1 by root 2 is equal to 2 by root 2, that is equal to root 2. So the maximum value is root 2. Okay. Now 10th question. Find the maximum value of f of x is equal to 2x cube minus 24x plus 107 in the interval, closed interval 1 comma 3. Okay, find the maximum value of same function in the interval, closed interval minus 3 comma minus 1. Okay, so in this case the interval is given, so we need to find out the absolute maximum value. Okay, so f of x is equal to this one, and f dash of x is equal to what we will get? F dash of x is equal to 6x square minus 24. Then equate this f dash of x into 0 to get the critical point. This implies 6x square minus 24 is equal to 0, and it implies 6 into x square minus 4 is equal to 0. and x square minus 4 is equal to 0 implies x square is equal to 4 implies x is equal to plus or minus 2. Okay, now we are considering the first interval. In that interval, minus 2 does not belongs to the interval closed interval 1 comma 3. Minus 2 does not belongs to closed interval 1 comma 3, so no need to consider that point. Okay, so what are the values of x? That is x is equal to 2 or critical point, and the endpoints 1 and 3. Okay, now we are going to find out the value of a function f at x is equal to 1, 2, 3. So f of 1 is equal to 2 into 1 cube minus 24 into 1 plus 107, that is equal to 85, and f of 2 is equal to 2 into 2 cube minus 24 into 2 plus 107, that is equal to 75, and we need to find f of 3 also, and thus f of 3 is equal to 2 into 3 cube minus 24 into 3 plus 107, that is equal to 89. So the maximum value is 89 at x is equal to 3. Now we need to consider the second interval, that is minus 3 comma minus 1. Okay, in that second interval, 2 does not belongs to that interval. 2 does not belongs to minus 3 comma minus 1. So here the values of x, that is minus 3, minus 1 and minus 2. Minus 3, minus 1 and minus 2. That is the values of x in the second case. Now f of minus 1, that is equal to 2 into minus 1 all cube minus 24 into minus 1 plus 107, and it is equal to 129, and f of minus 2 is equal to 2 into minus 2 all cube minus 24 into minus 2 plus 107, it is equal to 139, and f of minus 3 is equal to 2 into minus 3 all cube minus 24 into minus 3 plus 107, and that is equal to 125. So here the maximum value, that is 139. The maximum value is 139, and it is at x is equal to minus 2. So in the first case, the maximum value is 89 at x is equal to 3. In the second case, the maximum value is 139 at x is equal to minus 2. Now I am going to do the 11th question. It is given that x is equal to 1, the function x raised to 4 minus 62x square plus ax plus 9 attains its maximum value on the interval 0 comma 2, closed interval 0 comma 2. Find the value of a. So f of x is given, then f dash of x is equal to 4x cube minus 124x plus a. F dash of x is equal to 4x cube minus 124x plus a we will get. Now we need to find out the value of a, and it is given that at x is equal to 1 we have the maximum value. At x is equal to 1 we have the maximum value, and here the interval is 0 comma 2. Okay, just look at the interval. The endpoints is 0 and 2, and thus x is equal to 1. Only one possibility for that x is equal to 1, that is a critical point. Okay, the endpoint that is not is equal to 1. So the only possibility for that x is equal to 1, that should be a critical point. What is our critical point? Critical point means f dash of critical point. How we will get? We will equate f dash of x is equal to 0, and we will find out the value of x, that we got it as x is equal to 1 here. Okay, f dash of x is equal to 0 implies x is equal to 1 means this value should satisfy this f dash of x is equal to 0. That means f dash of 1 should be is equal to 0. F dash of 1 should be is equal to 0. Just listen. In this question, it is given that at x is equal to 1, the function has the maximum value. And just look at the given interval. The given interval endpoints is 0 and 2. Then what is the possibility for this x is equal to 1? That should be a critical point. Critical point means at x is equal to 1, thus f dash of x is equal to 0. That is f dash of 1 is equal to 0. And this implies, just put x is equal to 1 in this, then we will have 4 into 1 cube minus 124 into 1 plus a is equal to 0. That implies 4 minus 124 plus a is equal to 0. And thus implies minus 120 plus a is equal to 0 implies a is equal to 120. Okay, a is equal to 120. So the value of a is equal to 120. Find two numbers whose sum is 24 and whose product is as large as possible. Okay, here it is given that sum of two numbers is 24. Sum is equal to 24. And we need to find the number, that two numbers, such that their product is as large as possible. Okay, so I'm going to take the first number as x. Okay, I'm going to take the first number that is equal to x. Since the sum of first and second number that is equal to 24 and the first number is x, then we will get the second number is equal to 24 minus x. Second number is equal to 24 minus x. Now let p be the product of that two numbers. Okay, let p be the product of that two numbers. That we will get it as the first number into second number. Okay, product p is equal to first number into second number. Or this we can write it as 24x minus x square. 24x minus x square. Now we need to get the product is as large as possible. That means we need to get the maximum value for p. We need to get the maximum value for p. So here we need to find out here we need to use the second derivative test to get the maximum value. Okay, we need to use the second derivative test. So we got p, that is 24x minus x square. Now we are going to find out dp by dx. dp by dx is equal to 24 minus 2x. 24 minus 2x. And what is dp square minus d square p minus dx square. d square p minus dx square. That means the second order derivative. d square p minus dx square. 24, the derivative is 0 and minus 2 we will get. Now to get the critical point, we will equate dp by dx into 0. That implies 24 minus 2x is equal to 0. And we will get 2x is equal to 24, x is equal to, what we will get, x is equal to 24 by 2, that is equal to 12, x is equal to 12. Now d square p by dx square at x is equal to 12, that is, here we don't have any term which contains x, so that d square p by dx square, that is minus 2 itself and it is less than 0. It implies at x is equal to 12, we have the maximum. Okay, so at x is equal to 12 we have the maximum, and this point x is equal to 12 is a point of maxima. Okay, the point x is equal to 12, that is a point of, this is a point of maxima. So the product is maximum when x is equal to 12. So we got the first number, that is 12. And the second number, what is second number? 24 minus 12, that is equal to 12. Okay, so we have the product that is maximum when the first number and the second number is equal to 12. Now 14th question. Find two positive numbers x and y such that x plus y equal to 60 and the xy cube is maximum. We need to find two numbers x and y such that x plus y equal to 60 and xy cube is maximum. Xy cube is maximum. So x plus y equal to 60 means what we will get, y is equal to 60 minus x. Y is equal to 60 minus x. Thus I am going to take it as f of x. Given that f of x is equal to xy cube. Okay, f of x is equal to xy cube. It is given, and here this y we can replace it by 60 minus x. So x into 60 minus x all cube. X into 60 minus x all cube. That is our f of x. Okay, what we want to find, we need to find out the value of x such that this f of x is maximum. Okay, we need to find the value of x such that this f of x is maximum. So we are going to find out the derivative. So f dash of x is equal to, here we need to apply the product rule. So x into dy dx of 60 minus x all cube plus 60 minus x all cube into dy dx of x, and this is equal to x into 3 into 60 minus x all square into the derivative of 60 minus x, that we will cut it as minus 1, plus 60 minus x all cube into the derivative of x is 1. Okay, then 60 minus x all square is common, just take it outside. 60 minus x all square into, what will remain in the first term? Minus 3x will remain in the first term, and in the second term we will have 160 minus x, and this is equal to 60 minus x all cube into 60 minus 4x. Okay, 60 minus x all cube into 60 minus 4x. 4 we can take it outside from the 60 minus 4x. So this is equal to, if you took 4 outside from that term, we will get 4 into 60 minus x all cube into 15 minus x. Okay, 4 into 16 minus x all cube into 15 minus x. This is our dp by dx. Okay, this is our f dash of x. Okay, this is our f dash of x. Now I am going to find f double dash of x. Okay, f double dash of x is equal to, in that case also we need to apply product rule. So 60 minus x all cube into the derivative of 15 minus x is minus 1. The derivative of 15 minus x is minus 1 plus 15 minus x into the derivative of 60 minus x all cube, that is 3 into 60 minus x all square into minus 1. 3 into 16 minus x all square into minus 1 we will have. Now, okay, sorry, it is square, so we will have 2 into 60 minus x into minus 1. Now this is equal to 4 into, okay, actually the 60 minus x is common, that we can take it outside. So 60 minus x, and what will remain in the first term? In the first term we will have 160 minus x into minus 1 is there. Okay, so into minus 1 plus, and the second term we will have minus 2 into 50 minus x. Minus 2 into 50 minus x we will have, and this is equal to 4 into 60 minus x into, just multiply it, then it is become x minus 60. Okay, that is become x minus 60, and this is become minus 30 plus 2x, and this is equal to 4 into 60 minus x into x plus 2x, that is 3x minus 90. Now 3 is common, that also we can take it outside. So 3, if you took 3 outside, then 3 into 4 is 12. 12 into 60 minus x into, we will have x minus 30. Okay, x minus 30. Now we are going to equate our f dash of x into 0 to get the critical point. So f dash of x is equal to 0 implies, what is our f dash of x? 4 into 60 minus x all square into 50 minus x is equal to 0. From this, anyway 4 cannot be is equal to 0. 60 minus x all square is equal to 0, or 50 minus x is equal to 0. This implies x is equal to 15 we will get, and from this we will get x is equal to 16. Okay, so we got two values for x, that is x is equal to 15 and x is equal to 16. But the first value x is equal to 60, that is not possible. Why it is not possible? X is equal to 60 is not possible because it is given that x plus y is equal to 60. Okay, these two numbers are positive numbers and x plus y is equal to 60, that is given. X plus y is equal to 60, and since it is positive numbers, anyway y cannot be equal to 0, then x cannot be equal to 60. So since x plus y is equal to 60, x not equal to 60, x cannot be equal to 60. Now x is equal to 15, and this is our f double dash of x. We need to find out the sign of f double dash of x at x is equal to 15. So f double dash of 15 is equal to 12 into 60 minus 15 into 15 minus 30. Okay, 16 minus 15 into 15 minus 30, and this is equal to, we will get minus 8100, minus 8100 we will get, and it is less than 0. What do you mean by this? The second order derivative is less than 0 at x is equal to 15, so we can conclude that x is equal to 15 is a point of maxima. X is equal to 15, that is a point of maxima. Actually we need to find out the values of x and y such that x into y cube is maximum. So we got when x is equal to 15, that x into y cube is maximum. So x is equal to 15 is our one value, and we need to find out the second value, that is y is equal to 60 minus x is equal to 16 minus 50 is equal to 45. Okay, thus the two positive numbers is equal to 15 and 45.